Right, today I'm going to go through and show you how we can change an equation in standard form, quadratic in standard form, to one in graphing form. Right, so that's our goal here today, is to be able to come up with that. The method that we use to be able to do that is what is called the completing the square method. Now, we've used the completing the square method to solve quadratic functions. Now we're going to use the completing the square method to be able to change from standard form into graphing form. So here's an example. So if I have here y equals x squared plus 8x plus 1. The first thing that I need to do if I'm going to use the completing the square method is I need to look at blanking this area out. I need to look at getting rid of that plus 1. Okay? So the way that I'm going to do that is by adding a negative 1 to both sides. So now I have y plus negative 1 is equal to x squared plus 8x. And now I have this area here blank. Now the next step that you would use is you're going to go to your generic rectangle and you're going to try to make this generic rectangle into a square. And the way that we would do that is we would put our x squared term here, and then we have to take this middle term here, 8x, we have to take this middle term and divide it up evenly between these two spots. So here is going to be 4x, and this spot is going to be 4x. By dividing it up evenly, now I've created this where I have x and 4, and so now this side and this side are the same. And if we have sides that are the same, a rectangle with sides that are the same is a square. All right, so now I have my square. Now I need to complete this square. I have to complete the square by filling in this square right here. Right, and what I'm going to fill it in with was 4 times 4, which is 16. So now I need 16 in this spot. So I'm going to take that 16 and I'm going to put it over here, and I'm going to put plus 16. But for everything to stay in balance, I have to go over here and add 16 as well. Okay, so I have to add 16 to this side, and I have to add 16 to this side. So in doing that, now I have y plus 15 is equal to x squared plus 8x plus 16. Now that I have that, now I can use these two sides, x plus 4 and x plus 4, to rewrite x squared plus 8x plus 16. X squared plus 8x plus 16 is what's called a perfect square trinomial. So we can take that and we can change and rewrite this into what it would be in its factored form, which is x plus 4 squared. Right? Because x plus 4 times x plus 4 is x plus 4, that quantity squared. And so now to finish this, I would add a negative 15 to both sides. And I have y is equal to x plus 4 squared plus a negative 15. And now that I have my equation in graphing form, I can clearly see that here my a is 1. So this is neither stretched nor compressed. It's pointing up. And my vertex is at negative 4, negative 15. Okay? And again, our vertex is always h and k. So our vertex in this situation would be negative 4, negative 15. Right, so let's do another one. Right, this time I'm going to use y is equal to x squared minus 6x plus 7. Now in this one, again, I don't like to do subtraction, so I'm going to change that to adding the opposite. I'm going to change that to plus a negative 6x. Now again, for completing the square, we need to here empty out this spot. Okay, I got to empty out this spot at the end. So I'm going to add a negative 7 to both sides. So I have y plus negative 7 is equal to x squared plus a negative 6x. Now I'm going to use the generic rectangle and I'm going to make it into a square. Again, the way that I make it into a square, x squared, negative 3x, and negative 3x. I have to take this middle term and split it up evenly between these two boxes, and then I have to have my x squared term here in this box here. Now by doing that, this becomes x, negative 3, and negative 3. And now since I have this side and this side the same, all the sides are the same, therefore this rectangle is now a square. And now I need to complete that square, and the way I complete that square is I take negative 3 times negative 3, which is a positive 9. So I need to put a 9 in that spot. So I'm going to here now add 9. But whatever I do to one side of the equation, I have to do to the other to be sure that everything stays in balance. So I add 9 over here. So now I have y plus 2 is equal to x squared plus a negative 6x plus 9. Now again, x squared plus a negative 6x plus 9 is a perfect square trinomial. And being a perfect square trinomial, now I can rewrite it in its factored form, which are these two sides here. So its factored form is x minus 3 squared. And again, now to finish it, to get it finished in graphing form, I have to add a negative 2 to both sides to get y alone. So I have y is equal to x minus 3, that quantity squared, plus a negative 2. So now again, we have our a, h, and k, and once we have those, then we can know that, again, this is neither compressed nor stretched, and our vertex is at 3, negative 2. So again, our vertex is at 3, negative 2, which is h and k. And it's another way that we can go about doing this. All right, last one. I'll do one more example for you. Y is equal to x squared plus 10x minus 9. Now again, I don't like to do subtraction, so I'm going to change this to plus a negative 9. So here, again, I have to empty out this spot to be able to use my completing the square technique. So I'm going to add 9 to both sides. So now I have y plus 9 is equal to x squared plus 10x. Next, we go to our generic rectangle. And our goal is to take this generic rectangle and make it into a square. The way that we do that is we take our x squared term and put it here. And then we take our middle term and divide it up evenly between these two squares. So I have this is 5x, this one is 5x. Right, so now I have my x squared 5x, so now this side is x, this side is x, this side is 5, this side is 5. Now again, this side and this side are the same. Since the sides are the same, I have made a square. Now I need to complete the square by filling in this box. Okay, to complete that square, this needs to be 25. All right, so since this is 25, I need to put that in over here. I add 25 here, add 25 here. I get y plus 34 is equal to x squared plus 10x plus 25. Now again, I've created a perfect square trinomial here, x squared plus 10x plus 25, which can be written in factored form as x plus 5 squared. So I'm going to rewrite it in its factored form. X plus 5 squared. And then I have to get y alone, so I'm going to add a negative 34 to both sides. So I get y is equal to x plus 5 squared plus a negative 34. So again, we can clearly see that our a here is 1. So again, it's neither stretched nor compressed. Our h and our k are 5 or negative 5 and negative 34. So our vertex would be negative 5, negative 34. Now, the next thing that I need for you to do is you can watch this video again if you need more techniques. And then you need to go on to Desmus and work on the activity that I have for you there. You can find all of these things on your Google Classroom account, right? Thank you.